A massive asteroid is hurtling towards Earth, and in 2029, it will pass closer than some of our satellites. Could Apophis be the asteroid that finally collides with our planet, or will it be a wake-up call for planetary defense? Asteroid Apophis, a near-Earth object measuring approximately 370 meters in diameter, has captured the attention of astronomers and the public alike due to its predicted close approach to Earth in 2029. Discovered in 2004, this massive space rock was initially thought to have a significant chance of impacting the planet, triggering widespread concern and speculation. Over time, refined calculations reduced the likelihood of a collision, but the upcoming encounter remains one of the most closely observed astronomical events in recent history. The asteroid's trajectory, speed, and potential long-term orbital changes continue to be subjects of intense study, as even a slight shift could lead to different scenarios in the future. As Apophis hurtles through space at speeds exceeding 30 kilometers per second, its 2029 flyby will bring it within approximately 31,000 kilometers of Earth's surface, closer than some of our satellites. This unprecedented proximity provides scientists with a rare opportunity to study an asteroid in real time, observing its composition, spin, and gravitational interactions. The asteroid's close passage will be visible to the naked eye in some regions, appearing as a fast-moving star in the night sky. While current projections rule out an impact, the concern arises from what is known as the Yarkovsky effect, a minute but consistent force exerted by uneven heating on the asteroid's surface, which could alter its trajectory over time. Even minor deviations from its predicted path could have consequences for future close approaches, particularly in 2036 and beyond. The impact of an asteroid the size of Apophis would be catastrophic if it were to collide with Earth. Traveling at hypersonic speeds, its kinetic energy would be equivalent to hundreds of megatons of TNT, enough to level an entire region or trigger massive tsunamis if it struck an ocean. The devastation would be comparable to, if not greater than, the Tunguska event of 1908, which flattened over 2,000 square kilometers of Siberian forest. Although Apophis is not large enough to cause a mass extinction event, its impact would result in significant destruction, loss of life, and potential climate disruptions. Understanding and tracking such objects is crucial for planetary defense, as even smaller asteroids have demonstrated their destructive potential, such as the Chelyabinsk meteor that exploded over Russia in 2013, injuring over 1,000 people. The scientific community is leveraging advanced technologies, including radar imaging, optical telescopes, and spacecraft missions, to gather data on Apophis and refine our understanding of its orbit. Efforts to develop planetary defense mechanisms, such as kinetic impactors or gravity tractors, are underway in case future threats arise. NASA, ESA, and other space agencies have proposed potential missions to study Apophis up close, possibly deploying landers or impact probes to analyze its surface composition and structure. These studies not only aid in understanding the asteroid itself but also contribute to broader efforts in asteroid deflection strategies. As our knowledge of near-Earth objects expands, so does the possibility of mitigating potential threats through early intervention, ensuring that humanity is not caught off guard by an unanticipated impact. Despite the current understanding that Apophis will not pose a direct threat in 2029, continued monitoring is essential. The gravitational influence of Earth during its close approach could slightly alter its orbit, potentially setting it on a different path for future encounters. Scientists are particularly interested in studying how Earth's gravity may induce changes in its rotation or fracture its surface, leading to unforeseen variations in its trajectory. The study of Apophis provides a unique and valuable case study in planetary defense, offering a live demonstration of asteroid dynamics and space hazard assessment. As humanity continues to explore and expand its presence beyond Earth, the ability to detect, track, and deflect potential asteroid threats will become an increasingly vital component of our survival and planetary stewardship. Apophis may not strike Earth this time, but its close encounter is a stark reminder that our planet is not immune to cosmic threats. With advancing technology and global cooperation, will we be ready when the next asteroid comes knocking?